Welcome to qnawire.
Our question says that the speed amplifier in figure 9-75 shows block 1 of mass M1 sliding along an x-axis on a frictionless floor with a speed of V1 initial 4 meters per second, which I write as V1I. Then it undergoes a one-dimensional elastic collision with the stationary block 2 of mass M2 is equal to 1/2 M1. And then next, block 2 undergoes a one-dimensional elastic collision with stationary block 3 of mass M3, where M3 is equal to 1/2 M2. A, what then is the speed of block 3? B, what is the speed? And then C, the kinetic energy. And then D, the momentum of block 3 compared to block 1. Is it greater than, less than, or equal to? So we need to find those values and compare them to the speed of block 1. Okay, so for part A, we're going to use our equation here, which says that V2, first we need to calculate the velocity of block 2 is equal to 2m1 divided by m1 plus m2 times V1 initial. So this is equal to 2 over 1.5. If we replace we replace M2 with 1/2 M1, 1 M1 plus 1/2 M1 is 1.5 M1, and then the M1 on the top and the bottom cancel, so we're left with 2 over 1.5. Multiply that by V1 initial, which is 4 meters per second, and this comes out to be 16/3 meters per second. Okay. Now that we have V2, we can use that to calculate the velocity of block 3 after it's struck by block 2. So this says V3 is equal to 2 M2 divided by M2 plus M3 times V2. Well, here, M3 is 1/2 M2, so we'll plug that value in for M3. So you have 2M2 over 1.5 M2, where the M2s are going to cancel. So you have 2 over 1.5 times V2. And this comes out to be 7.11 meters per second. We can box that in as our solution for part A. Now for part B, we are asked if the velocity is greater than or equal to the velocity for block 1. Well, the velocity for block 1 is 4 meters per second, so which we were given. So V3 is greater than V1I. We can box that in as our solution. Part C wants us to compare the kinetic energy of block 1 to the kinetic energy of block 3. Well, the kinetic energy of block 3 is equal to 1/2 the mass of block 3, which we'll write as M3, multiplied by the velocity of block 3 squared. Okay, well, to compare that to block 1, so the kinetic energy of block 1 is 1/2 M1 V1 squared. So let's put M3 in terms of M1 and V3 in terms of V1. So this is 1/2. M1 is 1/4, or M3 is 1/4 M1. So this is 1/2 multiplied by 1/4 M1. Okay. And then V3 squared is 16/9 squared times V1 initial squared. This is because V3 is 16/9 V1. Okay, so this is equal to 64 over 81. And that's 64 over 81 times 1/2 M1 V1 initial squared. Well, 1/2 m1 v1 squared is the kinetic energy of block 1. So this is 64 over 81 times the kinetic energy of block 1. Therefore, K3 is less than K1. We can box it in as our solution for part C. Now for part D, we're asked to do the same comparative analysis for the momentum of block 3 and block 1. Well, P3 is equal to M3 times V3. And as we just stated, M3 is 1/4 M1. So this is 1/4 M1. And V3 is 16/9 V1 initial. So this equals 4/9 times P1. So therefore, P3 is less than P1. And we can box it into our solution to part D.